Good morning, everyone. So now we are going to solve this problem. The problem says given is a periodic signal and it is represented by x of t with period t is equal to 2, and also an impulse train is given with a period which is equal to 2. So we have to prove this. To prove this, first let us plot this signal which is x of t. So as per the equation, it starts at 0. I'm going to mark the points. And then right from 0 to 1, the magnitude of the signal is 1. And from 1 to 2, between 1 to 2, the magnitude of the signal is minus 2. Okay, so I'm just denoting this magnitude as minus 2 and this magnitude is 1. Now we know that the time period of the signal is equal to t is equal to 2. Next we'll plot the signal g of t, which is the pulse train, and it says del of t minus 2k, which means when k is equal to 0, del of t will be at the origin, and when k is equal to 1, it will be at del of t minus 2. So it will be at the point 2, and when k is equal to 2, it will be at del of t minus 4. So the next impulse will be right at 4. The similar thing follows for the negative values also. So at minus 2, we have an impulse, and then at minus 4, we have another impulse. And it goes on from minus infinity to plus infinity. Now we have plotted these two functions. The next one would be differentiating x of t and drawing x of t function. Okay. So as we all know, these two portions are discontinuous. Okay. So any discontinuity which can be represented with the help of an impulse when we differentiate it, and the strength of the impulse will be the discontinuity's strength. Okay, so write it here. If it is going to be a periodic signal, then the signal will be like this. It has to go to minus 2. Okay, so the discontinuity will be from minus 2 to plus 1, exactly 3 units. Minus 2 to minus 1, 1 unit, and then minus 1 to 0, and then 0 to 1. So right at origin, the discontinuity will be represented when we differentiate it with a strength of 3. Okay, and then right at 1, the discontinuity will be minus 3. Right at 1, the discontinuity will be minus 3 because it goes downwards. So we'll plot minus 3 here. Now this is our signal dx of t divided by dt. Okay, now we have to get this expression, and by getting this expression we should find out what is a1 and a2. Right, so g of t is this one. To find out, to get this origin function, g of t minus t1 should be at the origin, which means t1 should be equal to 0. So that gives us g of t, which is in the origin. Okay, and the strength of the impulse will be 3. So for the first function, dx of t divided by dt is equal to 3 into g of t minus 0. And for the second function, g of t should be shifted 1 unit towards the right. Okay, so g of t minus T2 should be g of t minus 1. And when we shift that, the magnitude of the strength of the impulse will be minus 3. So we can write that function as minus 3 into g of t minus 1. When comparing this expression with a given problem, we can say that a1 is equal to 3 and t1 is equal to 0. Similarly, a2 is equal to minus 3 and t2 is equal to minus 1. Okay, therefore, this will be our answer for the particular problem. Thank you.